Hey everybody, this is Larry. This is day 7 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about today's farm. So yeah, today for my workouts, I didn't do anything. Today's a rest day, and you work out hard, you grind hard, make sure you rest hard as well, and just once in a while just take a day off. It's fine. Your workout and your work or your lead code, whatever it is, will still be there when you want to get back. So yeah, I actually want to mix it up a little bit today. I feel like I've done this for a bit, but I haven't done it in a while, due to maybe marathon training, just being tired and stuff. But I still pay for it, so I might as well. But I will do a bonus extra problem today. One problem that I don't have a video for or I haven't solved yet, so definitely check that out. And yeah, if you don't think, or if you cannot find a video if you find a problem on Leetcode and I don't have a video for it, let me know in the comments and maybe I'll pick it for tomorrow. No guarantees, but we'll see how it goes, right? Anyway, today we have 25, 23, closest prime numbers in range. Okay, so given two positive integers left and right, find two integers num1 or num1 and num2 such that, okay, so they're in between, they're both prime, and the minimum amongst all pairs satisfying all of them. It's almost like a twin prime thing, right? I guess that is actually the name of the thing, but or like not the twin prime part, the closest prime. I forget what's the twin prime hypothesis. It's been a while, but yeah. How do I want to think about this? I actually don't remember the exact twin prime hypothesis, which actually may become in handy because I think there's like a hypothesis. Maybe we'll actually be a little bit lazy today and do the googling. But I mean, this is like research level math, so if I don't remember it, I'm not going to get it right. But yeah. But I think for most part there is, yeah, like x plus 2 could be a prime. Is very often we just have to find the next one, right? I don't know. But the first thing that you can do is take a look at is 10 to the 6, and of course with that you can you should consider using prime sif, right? There is this thing called a sif of errors. Man, I could never spell this correctly. I feel like there was a time when I could spell it correctly, but I haven't done ever. That's not even close. That is embarrassing. The sif, right, is something to Google on. I'm not going to do a full video on this part just because maybe I should in the future, but not for this particular video. And it is something that, one, comes up a lot on Leetcode and competitive programming, but two, not so much on interviews, to be honest. And then 3 is just that there only are really a couple of things you need to know about this, and you get the idea. And and the prime is one of the biggest use of sifs, but I would say competitive programming, there has been creative uses of this idea, right? And the idea here is that if you loop, like you have a for loop that loops like this, right, for I in range of n for some n, then yeah, if you do something like for j in I 2 times I 3 times I dot dot dot, right, this loop actually runs in actually n log n, surprisingly, right? Yeah, and if you want to write out the summation, it's going to be n plus n over 2, right, for 2 plus n over 3 plus n over 4, and then that's where you get the I think it's harmonic sum or something. Anyway, it's n log n, right? So it's interesting, or it's important to know, just because, well, I think this is not that intuitive. For me, when I was younger, when I was learning this, I always forget about it because I always think that this loop always looks n square or something like that, and it just looks too slow. But once you get used to it, then you see it in a lot of places and you're able to solve a lot of these problems, right? And that's really the idea about this. The key thing about, I don't know if I need it for Leetcode. Leetcode is a little bit silly sometimes. And what I mean by that is just pre-calculation in one place. You're not really supposed, or like, you know, with the layout, you're not supposed to, but Leetcode is silly, like I said. So I don't know, we'll see. But yeah, the way that here, and maybe I like to use m is equal to right? So then you have for I in range sub m plus 1, right? And we could just have a prime array, right, of just everything is true times m plus 1, except for prime of 0 and 1 is not, they're not primes, is what I mean. And then now, yeah, and you go to start at something, I don't know, it doesn't matter, it's two operations, right? So if prime sub I, so if it's a prime, then everything that's a multiple of this number is not a prime. That's the only thing you need to know. So actually, the way that I usually write this is j is equal to I, while for our purposes, we'll just write I times I plus I, but you can actually start at I times I if you really want to look for that optimization. If you draw it out and kind of work around the proof, you'll probably see why. But it's just that any prime that is smaller than I would have already been eliminated, right, as a result. So yeah, because by definition it's smaller than I, you're multiplying that by I, you already seen it, so you don't have to eliminate them. But it doesn't change anything anyway, for the most part. Maybe a little bit slower, right? So here, and that's it. Easy as day. And of course, there are some, like I said, there's another optimization you can do if you really like, which is that it's I times 2. That's just because no matter what, every other I will be even, right? And if they're even, then you already tick them off or something, probably. So yeah, it's a very minor optimization. Anyway, now we have all these primes, then it's straightforward, right? We just do a linear scan and we should be good, right? So for I in range of left, right plus 1, so it's inclusive, right? So maybe the past number is equal to, are there always a number? No, -1, okay. So maybe just like negative infinity or something like that. And then yeah, and then you have a best, which is infinity, and then yeah, if prime sub I, then pass is equal to I, but before that, best is equal to min of best, I minus pass, and that's it. That should be it. There might be some Leetcode specific things and also Larry specific things, but yeah, but no big deal. 19. Oh, I don't know why I'm returning the best gap, but of course this is not the answer. So we have to actually return, I don't know. So this is the best gap and the best smallest or something, or the best I is equal to none, right? So here, if I minus pass is less than best, then best is equal to I minus pass, and also best I is equal to the pass. The pass is the smaller one, right? And then now we can return best of I plus best, something like that, right? We have to do the -1 though, which is I guess the other thing. Best of I is none, then we just return -1. Oops. Yeah. Pretty straightforward. It may time out just because Leetcode is silly, but in general that should be okay. Yeah. And then the idea here is that yeah, okay, this timing you may be like, okay. Well, the thing is that the primes never change in between prime, right? Maybe that's obvious, maybe not, right? Because the result you can take it outside, just like you would say to your bully, and yeah, and that's it. Right? What was the biggest max? 10 to the 6 or something, right? Just add a little bit more in case, and that's it. And the reason why this is good is just the way that Leetcode sets up the prime. It doesn't mean anything. It's that it does only execute once, and for all the test cases, and you could do all this lookup. Apparently there are maybe slightly faster ways, but I'm not really going to worry about it. This is just a linear scan. I think the thing that you can do, of course, now that you already pre-calculate this, you can also do some binary search thing. Actually, let's do it. Why not, right? So yeah, so if prime sub I, then maybe we have just a list of p's, right? P append I, right? So then now we can binary search, yeah, yeah, oops. Well, we don't, I mean, we can do that, but we don't need to do all of it. So then maybe you could do something like, okay, now you have P, right? You want to do a bisect left on the on P. You want to search for the left number, and that is and actually, honestly, you can do some other. You can pre-process this even more if you really want, right? Because now you don't even. I mean, binary search is one way to do it, but you can actually pre-process this, because all the gaps between near primes are also the same, right? So you can just kind of, it's like a range minimum query or an RMQ over a million, which you can really do. So yeah, because then now you have all these numbers, right? So there are things you can do for sure, right? So, but for now, I'm just gonna be a little bit lazy. So this is the index. So then P sub index, right? So yeah, pass it. We can change that, right? So while P sub index is less than or equal to right, then we go, it is going to be prime. So if P sub index minus pass, well, I'm just going to copy it. Yeah, okay, fine. Pass is less than best. Best is equal to P sub index minus pass. And best I is equal to index, and probably P sub index. Sorry, and probably you could do a little bit better, but yeah, I mean, I'm just doing this as a lazy thing, so it's not a big deal, right? I forgot to increment. This is what happens when you have a while loop instead of a for loop. All right, come on. Dong dong dong. 10 will search you for 11. I mean, the idea is mostly right. I guess I'm missing. Am I? That's awkward, though. This would already be 11. Passes infinity, but then the next one is 13, right? So what's the issue? What are you talking about? And that's, we're searching for 10, so it should be the next prime. Yeah, I don't get it. All right, bonus things. Yeah, 11. So why is 11? So the next one is 13, right? 11, 13. Yeah, 15 isn't even in there. Oh, did I do that one? Oh yeah. This should be passed. That's why. I didn't even, for some reason I didn't even remember that 15 is not a prime. So that would, if I had noticed that, then that would have been very obvious that that's yeah. All right. I did think that this may go out of bounds just because the right is like a million or something, but I guess we got just added a couple more. I thought this was a possibility, but I was a little bit lazy to check it. But yeah. Yeah. Oh, that's actually not faster, huh? Okay. Well, that is all I have for this one regardless. Like I said, you can actually, I think RMQ will be pretty interesting if you want to upsolve it, but that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, oh yeah, the complexity. So it's going to be dominated by this, of course. But here, I mean, both this and the other way is still the same. It's just a loop, right? So yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.